right? Yep.
Okay. Thank you. So, hi everyone, I'm Klaus Wakonig. Thematically, we're going to stay in Switzerland, just move around 250 kilometers to the northeast, to a place that sometimes looks a bit like the Shire. So we're going to have the synchrotron source at the bottom, the SLS, the free electron laser is at the right at PSI. Then there's also a neutron facility, SynQ, muon source, proton therapy center. So we have quite a few facilities, but today the topic is more on the SLS and the SLS upgrades in terms of the upgrade project SLS 2.0 towards the fourth generation synchrotron. Now, in the past, we didn't really have a unified experiment control system. And this is sort of an opportunity for the SLS to actually revisit that and maybe merge the efforts into something that's a bit more coherent among beamlines. So if we're talking about the Beamline experiment control system, what we have in mind is that there is a Beamline user that actually wants to orchestrate the data acquisition, so it steers the data acquisition. But underneath what we have is still a control layer. And for PSI, this is mainly epics. So the Beamline experiment control system doesn't typically talk to that system directly, but talks to epics. Now there's a caveat that there's still quite a few devices at PSI that are not in epics, and they won't be implemented in epics. So essentially, we have to deal with sort of this ambiguity of those devices. And then, of course, the control layer would then talk to the devices themselves. Of course, not only controlling devices is interesting, but actually steering also data analysis pipelines. We already had a few talks on this. And then, of course, archiving data directly from the data analysis pipeline, but also archiving from the raw data that you acquire, of course. And during the entire data acquisition, of course, we also have potentially an electronic logbook system that needs to be integrated. And all of that sort of needs to be considered when you consider a larger experiment control system. Now, for the SLS, we went into the direction of a server-client architecture that is built around Redis as a central component. So you can essentially think of, okay, you have the client up here with an IPython client or some data visualization or a graphical user interface. There was a bit of a larger component, but it would still connect to that back server, as we call it. And in here, it's a server that is still composed of multiple smaller services. It's towards a microservice, not really microservice architecture, but service-based. And these services, they share messages among them. So essentially, the client would send a message, let's say, to perform a specific scan to Redis, and then the scan server would pick it up, process it, and if necessary, send instructions that the device server can pick up. And underneath, for the device server, we're then using the OFID abstraction layer from Blue Sky to have a unified interface across all devices. Doesn't matter if it's now epics or a custom REST API that someone wrote, we have a unified interface for that. The same is true for the file writers, essentially file writer writing Nexus files for us, the connection to external services such as SciCAD or SciLog, the electronic logbook, but also data analysis pipelines. Now the scan bundler here is essentially some sort of data bundler that is some data aggregation. There will be a talk tomorrow on that scan bundler and the extensions, because at the moment we are sending back events, so essentially aggregated data from back, but also Blue Sky events. And Matthias, who is currently doing a sabbatical at PSI, spent some time on extending that to Bliss data. So essentially back at that point can then emit not only back data, but also Blue Sky events and Bliss data. Now, as I said, it's built around Redis, and this is really the core of it. We have it as a central component, which means that it holds all user requests. It holds the scan queue. any status updates, any device readings from smaller devices. Larger devices would have their own data backend. It also holds potentially smaller data analysis results that you can immediately react on. So you really have that event system that allows you to tailor it to your needs. And all of that within Redis, well, actually on the Python side, is validated with Pydantic to make sure that when a message is actually sent to Redis, we are sure in what format it arrives there. So coming to the device integration, as I said before, this relies heavily on OFID. In that sense, we have a unified interface across all devices, and yet still we have mostly epics, which for us means essentially that most of the devices that we have to integrate are just a matter of writing one configuration, and there you go, and that's it. So it makes the rollout for us really easy and straightforward. Then, of course, you have some specific logic that some beamlines want to add to a device. So imagine that you have a detector that needs to have a certain setup procedure. Now, OFID provides these interfaces. They just need to be customized. And we customize them in a sense that we have essentially extensions that can be plugged into these OFID devices and then run customized setup procedures, even depending on the scan that the user just requested. Now, if you want to learn more about this, there's a poster by Christian on this scanning approach. Another topic is, of course, visualization, and that's quite a big topic. We sort of went into a way of again, sticking with Python, but combining it with Qt and in particular PyQt Graph. Now, this allows us to not only be fully compatible with Qt components, but also to have the high performance that PyQt Graph gives us. We moved quite quickly from PyQt 6 to from PyQt 5 to Qt 6, essentially mostly relying on PySide at the moment. There's still some compatibility with PyQt 6, but we're most likely going to drop this at some point. But for us, it's really important that all this data visualization runs in a separate process, because it cannot happen at all that the data acquisition stops just because you pushed through too much data to your plotting tool. So it runs not only in a separate process, but it also receives data directly from Redis, bypassing the client. So you can configure your plotting tool to actually receive that data. Now, in terms of components that we have, of course, it's not really surprising. I mean, plotting of normal 1D waveforms, then 2D scatterers with sort of a heat map. Imagine you have a beam position monitor that you want to plot on top of that. This is something like that. Then what I would have loved to have in spec is something like this one, a motor map. Imagine you want to align a pinhole. I had numerous occasions where I actually lost the position in spec, so this would have helped quite a bit. And then, of course, 2D visualization of data. Now, all of that, as I said, it's in a separate process, but we try to keep a similar interface for the user, similar to Matplotlib, but extended with the capabilities of back, in a sense that you can now actually request data directly from that. So you can directly talk to the plotting tool and tell it, plot my motor versus my beam position monitor. So SAMX versus BPM4i. At the same time, you can also send your custom data to it. And it just runs in a separate process, and you don't have to care about it. Of course, this also means that you can script it, right? You can have it in any script. You can react to events from back and essentially change that dynamically. Of course, not everyone wants to script. There are also occasions where you just want to create it ad hoc. You can simply select what you want to add and add it from within that interface. So at this point, we have more than 30 widgets that you can choose from through that interface. Of course, waveforms and images, but also the scan control, which means that based on the signature, and the Python signature that we have on the scan server, you can automatically generate that GUI. So there is no code needed for the user if they write new scans, and it simply generates that interface for them. They can customize it further, but essentially that is automatically done for them. And then last but not least, if you're building larger components, larger GUIs, like fully fledged applications, you can actually use the Qt Designer. Not sure if many people are familiar with the Qt Designer. At PSI in the past, this was quite heavily used for CQDM to generate these panels. Now essentially have it in PySite 6. So you have all the back widgets on the left, and you can simply drag and drop them. You can connect them with signal slots directly in Qt Designer, customize them, hide components, whatever you want, and then just launch it. You can even launch it directly in Qt Designer, because as soon as you drag it in, it's already connected. You can even see it here. It already shows the current position of the motor, even though you're currently not even running that system. If you want to hear more, there's also a poster by Jan on that framework. Now, the last topic I want to discuss is essentially how do we get that to the Beamline? Because, of course, it is more complicated. We have now sort of a full server client architecture that needs to be deployed, and needs to be deployed to many Beamlines. So how do we make that? Our approach is to have the auto-deployment, so essentially a trigger that runs from our GitLab instances with the specific configuration for the Ansible deployment that we have afterwards. Which means that the users, the Beamline scientist, not really the user, but the Beamline scientist, they can decide what version they want to use. They simply select that version number, run the auto-deployment, and they're done. Within a few minutes, 5 minutes maybe, they have that new version. If they notice that it doesn't work, for whatever reason, they can simply roll back. And I think the rollback creates quite a lot of confidence from the Beamline sides that they can actually try a new version and roll back quickly by themselves. They don't have to ask the IT support for that. There's also a poster on this by Ivan. So I'm almost over time. For the outlook, well, the phase 1 of the upgrade is around 11 Beamlines, and I think we're currently quite optimistic that we can cover all of them within the next couple of months to roll out back. Not all of these Beamlines will use back for the user acquisition, but especially the EMX Beamlines, they have their own GUI application, the A+ for that. So for the moment, we will probably stay with that. But all the other Beamlines will most likely fully transition to that. The second phase will then be 1 year later, most likely if everything goes according to plans. So for back core, we're at the moment currently just fixing bugs and doing maintenance, and the focus has really moved on to creating more GUI applications, a deeper integration also into the editor environment, so VS Code. By now we have essentially a widget that just presents you with VS Code that you can even control from Qt. And then, of course, the deeper integration into data analysis pipelines and potentially evocs with Bliss data. So thanks, everyone.
Okay, no, now it goes. Yeah.
Thanks for the talk. I was interested that you have deployment of all of your services from GitLab pipeline. We've been nervous to do that. And I also found it interesting that you said you got Beamline scientists or gave them the ability to do it themselves. How hard did you find it to train them to use GitLab and be happy doing that process?
It's definitely a learning curve. Not everyone is familiar with GitLab. But on the other hand, if you write them 2 sentences, go to this web page, click that button, it's done. So I think it's not that complicated if you don't ask them to change 15 files. Yeah. If you ask them to change 1 file and then click that button, I think that's okay.
And is this everywhere?
What do you mean everywhere?
On all 10 of your...
Yes.
This is how you do it everywhere? Okay.
Yes.
Thanks.
Everything's it. I mean, there are for sure some Beamlines that will not update because they're afraid of GitLab or they just don't care. then they will always stay on that version until we upgrade for them together with them. But yeah, there's a huge variety of beamlines.
Okay, one very last.
Very quick. So the pipeline, the GitLab pipeline, it's run manually then? It's a manual pipeline?
Yes, it's a manual pipeline.
Okay, I see.
You have to trigger it. I mean, it runs once you commit the changes. But otherwise, if you just want to redeploy, then you just click the button.
Okay, let's thank Klaus again.